Good morning, students. In earlier classes, we have discussed about the Laplace transformations, various properties of the Laplace transformations, various questions of the Laplace transformations, illustrative examples, and some problems of the Laplace transformations. Now, we will discuss the inverse Laplace transformation. So, inverse Laplace transformation. What is inverse Laplace transformation? As we have defined, the Laplace transformation of a function fx, this is equals to f. If the Laplace transformation of the function fx is equals to fp, then inverting this, the inverse Laplace transformation of fp with respect to x is equals to fx. Inverting the Laplace transformation, we get the inverse Laplace transformation of fp with respect to parameter x is equals to fx. So, if the Laplace transformation of fx is equals to fp, then fx is the inverse Laplace transformation of fp. Now we will calculate some standard formulas, some standard results for the inverse Laplace transformations. First, we know that the Laplace transformation of x raised to n with respect to p is equals to p raised to is equals to factorial n upon p raised to n plus 1. We know that the Laplace transformation of x raised to n with respect to p is equals to factorial n upon p raised to n plus 1. So, inverting this, the inverse Laplace transformation of factorial n upon p raised to n plus 1 with respect to x is equals to x raised to n. So, we get the inverse Laplace transformation of 1 upon p raised to n plus 1 with respect to x is equals to x raised to n upon factorial n. This is the first result. The inverse Laplace transformation of 1 upon p raised to n plus 1 is equals to x raised to n upon factorial. If we replace n by n minus 1, then we get inverse Laplace transformation of 1 upon p raised to n with respect to x is equals to x raised to n minus 1 upon factorial n minus 1. This is the first result. The inverse Laplace transformation of 1 upon inverse Laplace transformation of x raised to n. The another result, we know that the Laplace transformation of e raised to ax with respect to p, as we know that this is equals to 1 upon p minus a. The Laplace transformation of e raised to ax with respect to p is equals to 1 upon p minus a. So, inverting this result, we get the inverse Laplace transformation of 1 upon p minus a with respect to x is equals to e raised to ax. This is the second result. We also know that the Laplace transformation of sin ax with respect to p is equals to a upon a square plus p square. The inverse Laplace transformation of sin ax is equals to a upon a square plus p square. So, inverting this result, the inverse Laplace transformation of 1 upon a square plus p square with respect to x is equals to 1 upon a sin ax. This is the inverse Laplace transformation of 1 upon a square plus b square. Similarly, we know that the Laplace transformation of cos ax with respect to p is equals to p upon a square plus p square. So, inverting this result, the inverse Laplace transformation of p upon a square plus p square with respect to x is equals to cos of x. Similarly, for the hyperbolic functions, we know that the Laplace transformation of hyperbolic sine ax with respect to p. The hyperbolic sine ax, Laplace transformation of this function is a upon a square minus a square, rather not a square, p square minus a square. So, inverting this result, the inverse Laplace transformation of 1 upon p square minus a square with respect to x is equals to 1 upon a hyperbolic sine ax. Another result for the hyperbolic function, hyperbolic cos x, the Laplace transformation, we know that hyperbolic cos ax with respect to p, as we know that this is equals to p upon p square minus a square. So, inverting this result, we get the inverse Laplace transformation of p upon p square minus a square with respect to x is equals to hyperbolic cos ax. Another important example or result of the inverse Laplace transformation is the Bessel function of order 0. As we know that the Laplace transformation of J0ax is equals to the inverse Laplace transformation of J0ax is equals to 1 upon under root p square plus a square. So, inverting this result, the inverse Laplace transformation of 1 upon under root p square plus a square with respect to x is equals to J0ax. So, these are the initial standard formulas for the inverse Laplace transformation of various functions, which are to be used in the next problems or next results. We will use these problems or these formulas for the results we will prove again. So, thank you very much.